Alright, welcome back and thanks for tuning in again. If you're new to this channel, welcome. My name is Mike. I work on all kinds of generators, big and small, old and new. We got a little bit of an interesting project here today. We're going to be converting this Chrysler 225 Slant 6 to fuel injection. Going to put a Holly Sniper EFI on it. So this is my first time doing this kind of job, so I thought it might be interesting to make a video on it. So let's get started. Let's give a little bit of backstory on this genset, why it's here, and what I intend to do with it. So the owner, who is also a viewer, got in contact with me, mentioned he had this genset. He picked it up cheap at a county auction. He had it to a couple different mechanics to try to get it to work correctly and bring it up to modernize it a little bit. One thing led to another. It got left outside for a while with no muffler on it. So this pipe, this vertical pipe, was just sitting open. Ended up filling the engine with water and doing some damage to the cylinders. So I had to rebuild that engine. It's a 225 Chrysler Slant 6 industrial engine. The famous Leaning Tower of Power, as they call it. So had to rebuild the engine. We ended up going with a new generator end. The customer wanted 30 kilowatt single phase. The original generator end was a 30 kilowatt three-phase unit. We could have reconnected it for single phase, but we would have been reduced to 20 kilowatt. So brand new generator end, rebuilt engine. Again, we had the board oversize, new pistons, rings obviously, new bearings. Oil pump, water pump, head was going through, so it's a pretty much a new engine here. Record radiator, so it's a new unit, we could say. Well, he wants to be able to use this on gasoline fuel in mostly standby applications. So we need high reliability and the ability to start without any human intervention. So the thing's just got to start up and run whenever it's signaled to. We opted to go with the fuel injection conversion, mainly because in my experience and his as well, carburetors can be troublesome, especially when they sit for long periods of time. We don't want to have to worry about the choke sticking or the choke not working, and we're hoping to get a little bit more fuel economy out of that Sniper EFI compared to the carburetor. Speaking of carburetor, here it is. This is the original. It is a ball and ball made for Chrysler. So I did have the engine running on this carburetor. It seemed to run okay, but again, we want to update it. Sitting right next to it is the original governor. This is the belt-driven Pierce, I think. Yeah, it's a Pierce. Belt-driven Pierce governor. This was not even in service when he brought it to me. Somebody in the past had converted this to a Generac style stepper motor throttle actuator, electronic governor. And those things are a nightmare to begin with. They use the generator output frequency as their speed signal. And well, while they do work, they're just not the greatest. So I'm going to go with a... well, this is an old used barbacoa actuator, but we're going to go with a completely new governing system utilizing one of these linear actuators made by Governors America, Governor Controller, and a mag pickup. We'll see that in a little bit. But today, what I want to do is get the throttle linkage hooked up and set up. Here we got the linear actuator. This is has about a 7/8 stroke, so we need to translate this motion here into the rotary motion of the throttle body. So we're going to have to build a little bracket there and do some testing and see if we can get that working. And then we can hook some fuel up to this thing and fire it up for the first time on the fuel injection. Let's talk a little bit more about that before we get started. A lot of talking here. So this is the Holly Sniper EFI fuel injection. This is the replacement for the Autolite 1100 series carburetors. Now they claim that this will support an engine up to 200 horsepower. So We should have no problems here with this engine. This only needs to make, what, maybe 70 horsepower tops at 1800 RPM for the generator end. But there's the part number that I'm using. Also, so this here part number is just for the kit, which contains the throttle body, the wiring harness, and the little HMI interface. So they give you this little quick start book. To go along with this throttle body, I ended up, we'll take a walk over here, some of the wiring harnesses. I bought this kit here, fuel system kit. This contains the primary and secondary fuel filters, a piece of fuel injection hose, and the fuel pump. So both of those kits together represent a pretty significant investment on this thing. So hoping that we pay off with high reliability and improved fuel economy. Now the throttle bore on this is quite a bit smaller than the original ball-and-ball carburetor. Well, quite a bit smaller is relative, so maybe a 1/4 inch smaller. So I had to make this adapter plate here. Let me set this gasket aside so you can see how we got a tapered bore there. And then a similar new adapter here because the stud spacing on the EFI is more narrow than the original carburetor. So let's go ahead and put that back on there. We'll get it mounted, and I'll show you how I'm going to set this throttle linkage up. When you buy one of these Holley throttle bodies, they give you this little like linkage connector ball stud thing installed on this far hole on the throttle lever. So I removed that and I drilled a second hole. These are both 3/16 now, 3/16 diameter. So like I mentioned earlier, we've got to translate this vertical, more or less vertical travel of the linkage into a horizontal travel to mate up with the actuator's push and pull effect. So I had toyed around with the idea of removing this lever completely, making a new lever and attaching it to the throttle shaft, but I don't think I want to get involved with that. So what I'm going to do is adapt a little plate. This is a piece of cardboard here just to mock it up. Attach it to the existing throttle lever and then have my new linkage be able to connect at some point, maybe up in this area. I'm actually going to attach this piece of paper and we can visually see how the lever is going to interact with that. I don't know if you can tell, but I've got two marks here on this piece of threaded rod. One mark when the actuator is fully retracted lines up with the center of the shaft, and one when the actuator is fully extended lines up with the center. So you can visually see that's the amount of travel we gotta deal with. So we gotta change this approximately 90 degrees of rotation into that 7/8 inch of travel. Let me put this little piece of paper on. All right, so I'm going to try to give you a better view of what I'm trying to accomplish here. So we've got our travel for the actuator, and we've got, look at this blue dot right here. So that is where I think we need to have the linkage connect. So when I rotate the throttle from idle to wide open, you see the movement of that dot left to right, right to left. We need the actuator linkage to meet up with that. It's kind of hard for me to see it. I'm looking at the screen of the camera. It looks pretty close. I think it'll work just fine there. Now, one other thing is, when you're setting one of these actuators up, you don't want to have the actuator stop the throttle, if that makes any sense. So you always want the throttle movement to be fully within the travel of the actuator. So when the throttle is at idle, you want the actuator's travel to be just off of what would be idle. And when the throttle is at wide open, you want the actuator travel to be just under what its maximum stroke is. That goes with a rotary actuator or a linear actuator like this. So I think what I'm going to do is make this out of aluminum or something easy to work with, and actually mock it up for real and see what it feels like. Now I'll have a little bit of adjustment with the screw here and the linkages, the little ball ends. But all right, let me try that. All right, here's one more look at this dot before I drive you crazy. So I've got the caliper here set to the length of the travel for the actuator, and you can see when I move this dot, move this linkage, you see the dot moves well within the distance between the two caliper points. So I think that's going to work just fine. All right, well, I've been busy since the last clip. Got my little linkage here made up. Just a little piece of aluminum, little dog leg there. You can see the operation. Let me switch hands here. So it is very, very close lengthwise. See the throttle butterfly down there? It doesn't quite reach wide open throttle. Sorry about that. So it doesn't quite reach wide open throttle. Now I could move this attachment point slightly closer to the throttle shaft to allow me to get more rotation for the same amount of travel. But I think I'm going to leave it alone right now. Once we get the throttle body powered up, we'll be able to see the throttle position sensor's readout. So we'll be able to see where we're at as far as we should be at 0 throttle now, and I'm curious to see how close we are to wide open when we are fully extended. We shouldn't need to go to wide open throttle for any length of time in normal operation. If we got to tweak it, we will. Speaking of the throttle body, we're pretty much ready to power it up. So I didn't show this earlier. I got my oxygen sensor installed here. That's connected. We got that kind of looped around here. One thing I don't quite like about this, but I guess they had to do it for space considerations, is I don't really care for these legs coming out for the harness. They got, let's see, 1, 2, 3, 5 little harnesses coming out. It would be nice if there were 5 plugs here, and then you could just make the harness your own length. But this is fine. I understand why they did that. So we got our oxygen sensor. We got a big connector here, which is a bunch of auxiliary inputs and outputs. We're not going to be using that. This one over here goes to our water temperature sensor there. That's a little bit short. I'm going to have to extend that. So we're going to have 2 water temperature sensors, one for the fuel injection, and this one's going to be for the genset controller. Let's see, what else we got? So the main power harness is set up over here. We got our battery positive and battery negative input. This yellow wire runs over to the negative post of the ignition coil. That is the tach input, or the, well, engine speed input to the throttle body. And there's a little pink wire here that comes out. That's the ignition circuit, they call it. So I opened this piece of loom up. I removed that because I was looking at this and I wasn't quite sure how it was set up. It turns out they have a splice in here for battery positive and a splice for that ignition circuit. So when you energize the ignition circuit, it automatically picks this relay up, which is the fuel pump relay. It also powers up the logic in the throttle body. I thought the throttle body would control the fuel pump, but apparently not. It seems to be, maybe that fuel pump has some pressure regulation or start and stop switch built into it. Let's go around the other side. Actually, got the tripod over there. We'll go around. Anyway, the blue output wire here is from the relay going to the fuel pump. Let's walk around the other side. Let me move this thing. Got our little HMI hooked up here. They give you a pretty long length of cable. What's the dog barking at? Probably nothing. That's plugged in here. Get that pink wire going to a toggle switch that's going to serve as our ignition for the ignition, actual engine ignition, and the ignition switch for the throttle body. And then, yeah, so here's the fuel pump that I got in the kit. Came with a primary and a secondary fuel filter, and we just got that routed into a 5-gallon can of gas. I'm hoping this fuel pump should suck a prime. That's probably about an 18-inch rise. If it doesn't pull a prime within a couple seconds, we'll figure something else out. So I think we're ready to power this thing up. Let me get the battery hooked up, and we'll be back in a sec. We'll follow the quick start guide. All right, well, the battery's landed, so we're about ready to power this thing up. Now, initially I thought just a second ago that the fuel pump was going to run continuously, but I just took another look at the wiring here. So as soon as we flip the ignition on, this pink wire is going to go to battery positive, 12 volt, to the coil. I thought that would immediately run the pump, but this blue wire I thought was tied to ground. Sorry about that. I thought this was automatically tied to ground, but it's not. They have it called fuel pump output. So that must mean that the throttle body is going to regulate the fuel pump. So when we power up, the only thing that should happen is the little HMI should light up and be ready to operate. Let's see if that happens. Okay. All right, so we're going to follow along with this right here. So select Wizard from the main menu. Okay. Select TBI type. Gotta find the Auto Light 110. Oop, back. Oh wait, here we go. Here's down arrow. Or the Auto Light 1100. That's it, right there. Next. Number of cylinders 6. Next. You still in the frame? No, there you are. Next. What's going on here? Engine displacement. Okay, 218. So this is a 225. Let's 225. Next. Target idle speed. Let's set that up to say 700. Nope, too high. You know, they gave you a little stylus. Maybe I should go grab that. Yeah, hang on. Let me go grab the little stylus they give you. Look at me all tech savvy with my little stylus. There you go. Okay, next. Next. Cam type. Stock mild. Well, that's our only option. RPM signal. Coil negative. There's a couple different options, obviously. Let's see, what are the other options? Looks like that's it. So coil negative, that's what we're using. Next. And that's the file. So let's see. We jumped ahead without turning the page there. Right, after answering all the questions, press the start key. Got it. Uploading. Oh, there's the fuel pump. Oh, I just heard it suck a prime. We are up to 60 psi. Said it should run for 5 seconds to prime it. Please cycle the ignition to complete the operation. Okay. Cycle. Okay, ignition off. Ignition on. Okay. Fuel pressure is what? 52 pounds. Okay. 52 psi. No leaks, right? That would be bad. It looks like 50 right on the nose. Okay. Move this out of the way. Right. We saw that. Make sure all the sensors are reading properly. Let's do that. So, pre-start, startup. On the home screen, select the monitor icon. Okay. Monitors. Idle, learn, closed loop sensors. That's what we want. Map. That's our manifold absolute pressure. It gives us a little thing to follow here. So, engine RPM should show stall. Where's that? We don't have that here. But map. TPS should read 0. We got that. Map 101, 95 to 102. We're pretty much at sea level here. Coolant temp 62 degrees. That seems a little off. Maybe that's as low as it reads, because it's probably about 45 out right now. IAC position and the battery 12.6. That's good on all gauges. TPFs. Where do we see the engine RPM at? Engine RPM, there you go, stall. That's correct. IAC position 95%. Alright. C, idle setting, throttle plate setting section. Alright. So we go through all that. We did all that. Verified 55 to 65 psi. Right. Initial setup screen. Crank the engine, look at the RPM parameter. Initial setup. Are we there? There we go. Okay, so we've got to crank the engine over, make sure we get a crank signal. Then it should fire up. All right, let me go get my starter button and we'll hook that up. Okay, starter button's hooked up, ignition is on. I'm gonna crank it and we'll see if we get our RPM signal there and see if it starts. Ready? That was a pretty good startup, huh? Engine RPM 700 something. Throttle position at 0, of course. IAC position 100%. battery voltage dipped quite a bit. We don't have the alternator hooked up either. Make sure we got oil pressure. Yep, 45 pounds. Okay. Excellent. Okay, after startup, once we started, check for any fuel leaks. We got that. Let it warm up for some time. What's our engine temp? Okay, it's coming up a little bit, 77. Go back, monitor, multi-gauge, sensors, manifold pressure, air-fuel ratio, timing. We're not adjusting the timing, so that's fixed. The IAC is at 100%. Probably because it's trying to maintain that high idle. Let's see, duty cycle. I think that's the injector nozzle. Battery voltage. That battery's pretty weak. Throttle position at 0. Let's see, vitals. Alright, well, I think I'm going to let it warm up for a while. Where's our fuel at? Yeah, I don't think it starts learning until it gets to 160 degrees. And it's going to be a while until we even approach that at idle. Where do we find our engine temperature at? Back. Coolant temp 131. Okay. It's getting there. Man, it's so quiet. Of course, it's only at idle. I should also mention I've got the voltage regulator disconnected on the generator. So the only voltage the generator's making is residual. You don't want to idle a generator like this, or any generator with an automatic regulator, without just first disabling the regulator. I better make sure this wire isn't getting burned on the exhaust. Nope. Alright, we'll be back in a few minutes. Alright, well, we've been idling for a few minutes now. The idle seems to have come down. So we're at 176 degrees. Let's see. HVAC sensors. We were just there. Idle. So let's see, the IAC is at 82%. TPS is still at 0. We're at bouncing around RPM wise. So there's a little procedure here. Once we're at operating temperature, idle speed can be set to what it was configured to in the wizard. We set it to 700. To do this, open up the initial startup gauge screen. I think we're there, but it says idle live data for some reason. I don't know if that's, I don't know. We'll try this anyway. Adjust the idle screw until the IAC position reads between 2 and 10%. So I guess that means increase or turn the idle screw in to open up the butterfly. So that should be taking the job of idle speed away from the IAC. So we're going to get it to 2 and 10%. Watch the TPS value and make sure it stays at 0. Okay. So I'm gonna turn this screw clockwise while we watch the IAC and the TPS. So the TPS is coming up, the IAC is going down. And we want it between 2 and 10%. Right. Doesn't seem to be going any lower than 20 now. Huh, that's interesting. Yeah, now the IAC's picking back up. I haven't tried actually revving it yet. Remember, it's an 1800 RPM genset, so we never really need to get past 1800. I'm going to rev it a little bit past that just for the heck of it, but I don't want to overspeed the generator end. You can see how little throttle travel it requires to get us to 1800. What was that, a throttle position of 10%? Okay, so it seems like we're getting closer. Our IAC position is now 15%. Throttle position is still at 0. The target is between 2 to 10. So maybe it just needs to cycle a little bit, and we're hovering closer to 700 now. Interesting. I think the next step will be getting the governor hooked up so that I can more easily control the engine speed rather than fiddling with it by hand. I'm going to see if I can set the idle screw high enough to get the engine to rest at 1800. That's pretty cool, huh? Wonder if we can see like the fuel spray in here. Try a hard rev. Oh yeah, you can see it. See that? I think that was the fan belt squeaking. Pretty cool. Looks like I'm starting to burn my exhaust gasket there. I didn't have any graphite paper, so I just used a regular gasket. Got to get a proper exhaust gasket. Starting to burn some anti-seize off of some bolts too. Fun stuff. Well, I think that's going to be about it for this video. Accomplished the goal of getting the EFI at least to its basic settings. I don't know if it's still in learn mode or what. I gotta read more about this. This is just a quick start guide. There's a whole big manual available online. I really gotta read through that. Okay, current learn. This percentage of fuel the ECU is adding or subtracting. Yeah, I gotta read through this a bit more and see what I need to do to actually get this thing to thoroughly learn its job, its application. Being this isn't really it's not an automotive application, I'm kind of limited on the testing I can do. Obviously, I can load the generator to get the throttle position higher and get the thing under load, but I'm pretty much going to be stuck at 1800 RPM. I can't rev it up to 2000 or 3000 RPM or more, like it would see in an automotive application. Kind of the reason I went with the Holley versus other manufacturers of the fuel injection. I actually called Holley and spoke with one of their tech support guys, and he indicated that there have been other people in the past that use these in industrial applications, fixed speed applications. So that kind of gave me some assurance that it would work well in this situation. Now I guess we just shut her down to stop it, right? Just like turning the key off. Okay, well, I hope that was interesting for some of you. Believe me, we're not done with it yet. You know what we still got to get the governor hooked up. We'll come back in a separate video for that. Get this thing to learn. Once we get the governor hooked up, I can hook a load bank up to the generator end and work the engine, break the engine in. Remember, this thing only has, I don't know, how long have we been running it? 20 minutes? And I think I made it run it another half hour before that, so I don't even think the engine has an hour of runtime on it yet. So, all right. Well, thanks for watching.